So, good evening, everyone. Welcome back to Accounting Analytics session. And today we are discussing about the decision tree. So, as part of Accounting Analytics series, today we are going to discuss about one of the supervised technique, nothing but the decision tree, right? So, before we further proceed, let's understand and let's try to recap what all we discussed till now. So, in the previous sessions, we have understood about what is accounting, what is machine learning, and what are its application. So either it can be in auditing or it can be in taxing. And like when we talk about accounting, we always think about the transactional data, right? So like the past data, the historical data of a specific business. So basically accounting analytics explores how the financial statements data as well as the non-financial metrics, so these two can be linked, and we can identify the financial performance of a company or a business. So this is about the accounting analytics, friends, and that we have seen till now. And as part of the series, we are discussing about various types of techniques. And in the previous sessions, we discussed about k-means clustering and k-nearest neighbor. And today we are going to discuss about decision tree, which is one of the supervised learning technique. And yeah, let me get into the PPT. So this is our agenda. So first, let's understand the theory about decision tree, friends, and then we'll implement by looking into a simple use case. So a decision tree is a tree-like structure in which internal node represents test on an attribute, and each branch represents outcome of the test, and each leaf node represents the class label, and which is nothing but the decision taken after computing the all attributes, right? And as you can see here, the image, that we have different terms, right? Like types of nodes, root node, branch node, leaf node. So basically imagine tree. Try to imagine a tree, friends. So where it has roots, the starting, and also we have the branches and the finally the leaves. So if at the leaves, the tree will end. It is not further expanding. Similarly, so where the tree is starting, we call it as a root node. For example, let me try to draw. So if you talk about the root node, let's say this is a root node. From root node, we will have branches. So let's say I have 2 branches. Okay, let's say 3 branches, and they are again connected. So it's like hierarchy, friends. So where from root node to branch nodes. So we have a connection, and from here we can have the leaf nodes. So leaf node is like ending of the tree. Let me represent by just using a circle. And yeah, here we go. So further we cannot expand it, friends. So these are the leaf nodes. So this is called the root node, and this is called these are called the branch nodes, and these are called the leaf nodes. So at leaf nodes, your tree will end. Right? We are starting from roots and we are ending at the leaves. This is called a decision tree. Now, our objective is to consider the root node and then classify our data. Let's say here the example we are going to take is audit risk. So I hope all of you are aware of audit risk, but anyway, let's see that while looking into the programming example. Yeah, now let's say there are 3 types of audit risk, and so which type of audit risk is my given transaction? We'll look into that, right? So now I'm trying to classify the given audit risk into its various types. Or also, we can also consider the audit risk, whether is it an audit risk or not a risk. When you have misstatements in the transactions, in the financial statements, we usually call it as an audit risk. So this is the example we are going to look into it. And let's understand few more details about the decision tree. So how to build the decision tree? So first, use the training data to build the model. And tree generator determines which variable to split at a node and what will be the value of the split. So as you can see, this is the root node, friends. Now from this root node, we try to establish the variables. We try to split it into variables, and each variable is again a branch node. So from branch, so the decision to stop or split again has to be made, right? So whenever we don't have the further classification, we can quickly stop our splitting our tree. And then we can assign the terminal node to a label. So a leaf node is nothing but a terminal node. And at the end, we'll try to add up one label to it. We give one category. So yeah, and decision tree is also called as the greedy algorithm, friends. So why it is called as greedy algorithm? What are its properties? Let's try to understand. So a decision tree is constructed in a top to down recursive divide and conquer manner. So we try to establish the decision tree based on the recursiveness and also based on the divide and conquer. So it's like splitting the data and then achieving our objective. We are trying to split our data and achieve the objective, right? That is called divide and conquer. And at start, all training examples are at the root. Like similarly, like our hierarchical clustering, in decision tree also, we have our entire data at the root node. And attributes are categorical. If continuous, they are to be discretized in advance. If the data is continuous, we have to convert them into discrete data. So we have already discussed that the data is of two types, right? Continuous data and discrete data. Continuous data means numerical data. Discrete data means categorical data. Even though if we have the continuous data, we have to convert it into discrete manner. And at like if input data is partitioned recursively based on the selected attributes, we have to partition the data, the given data, based on the selected attributes. And test attributes at each node are selected on the basis of the statistical measure information gain. So this is one of the key term that you all need to know, nothing but the information gain. So based on the information gain, we will decide which node should go first as a root node. And next comes our conditions for stopping the partitioning. And all samples for a given node belong to the same class. Whenever the all my observations, all the records are belonging to the same category, then we can stop our partition of the decision tree. And there are no remaining attributes for further partitioning. Then also we can stop the splitting of the tree, and majority voting is employed for the classifying the leaf. And of course, when there are no samples left, nothing but when there are no observations left, we can stop our splitting the decision tree. So let me go on to the next slide. Yeah, so next we have something called as entropy, friends. And entropy helps us to identify the best attribute, or it helps us in the splitting of the tree. So as you can see, we want to use the attribute that does the best job, nothing but splitting up the training data. So, but this can be measured using entropy and information gain. So you might have listened about this entropy while we are while maybe you're in schooling days, when you're talking about the solids, liquids and gases. So where there this entropy word you might have heard. So similar, a same definition entropy has, and we are trying to define the the impureness or the disorderness of our data through entropy. So similarly, when we talk about the measure, the states of matter, and when we're talking about the solids, liquids, and gases, you might have you might have heard something like the disorderness of the molecules in the solid is very less. It's zero. But whereas in liquid, because they are moving, there is some disorderness, and but which is less than the gases and more than the solids. And if you talk about gas, the molecules that are packed in a gas are loosely packed and they have the highest disorderness, right? So the same way in our data, the samples, the categories that we have, we try to measure the entropy for them, the disorderness of them, right? And coming to the next point, we will find the entropy of the output values of a set of training instances. And if the value split to be 50-50%, and we set it impure as 1, and if output is 0, we set the purity as 0, right? And if the output values are split 25-75, we set the impurity to 0.81. So you might be wondering, so how did you get all these values? So we'll go into that part. Let's see some formulas, how it can be calculated. And then we have the information gain, friends. So the information gain is based on the decrease in the entropy after a data set is split on an attribute, nothing but a root node, a root attribute. So constructing a decision tree is about finding the attribute that returns the highest information gain, which is nothing but the most homogeneous branches. So this is the entropy, friends, that we are using. Yeah, and this is what I'm talking about. We have a specific formulas to find out the entropy and the information gain. So for example, you can see here the statistical measure entropy, expected information, which is also called as entropy, and it is needed to classify the tuple. So we have info D, we just call it as info D, information of a particular component D. And then we have like minus sigma Pi into log Pi, right? This is also called as a cross entropy, friends, categorical cross entropy, which is mostly used when we have the categorical data. When we want to look into the categorical data, like classifying it, we use this cross entropy. Basically, it is called as categorical cross entropy. When you have more categories, when you have only 2 categories, we call it as binary cross entropy. And then we have the information gain, information needed and information gain. So information needed after using A to split D into V partitions to classify the D, right? It is given as, so D J by and D mod D into information of the D. So what is this information of D? Which is nothing but the entropy. Right now, after we got the information needed and also the expected information, which is entropy, now we can find out the information gain. So gain is equals to the entropy minus information needed. So now whichever attribute has the highest gain, that is considered as the root node for the decision tree, right? Whichever attribute has the highest gain value, that is considered as the root node, right? So I hope you all understood some basics about the decision tree, and let's quickly look into the example, friends, and we'll try to implement this decision tree in our accounting data. So we are going to consider today the audit risk data. So let me quickly explain you the objective, and then we'll look into the solution. So this is the data, friends, but let me just walk you through the business understanding, the problem statement. So as you can see, there are total 777 firms, and those data we have collected, these are from the 46 different cities of a state, and that are listed by auditors for targeting the next field audit work, and the target officers are listed from 14 different sectors, right? So this is my data from the 777 firms. And then we have various columns, friends, like we have sectors code, the location, the IDs. We are taking the IDs rather than the names. We are just taking the ID. And then we have various parameters and the scores. So you can also see some risk A, risk B, risk C. And we also have the risk D, right? And at the end, you also have the types of risk. So by computing all these probabilities and the various risks, we are now coming up with inherent risk, control risk, and the detection risk. So which we have discussed in the previous session. So the same risk we are trying to take the same data, and we are trying to establish this particular problem. So let's do one thing, friends. Let's try to understand what is this audit risk is all about, and then we'll go into the problem, right? So yeah, likewise, we discussed in the previous session about the audit risk. Let's recap and let's look into it. So basically, audit risk is the risk that the financial statements are materially incorrect, even though the audit opinion states that the financial reports are free of any material misstatements. So whenever we have a material misstatement, we just call it as a audit risk, right? So audit risk may carry legal liability for a certified public accountancy firm, right? That is performing an audit work. And auditing firms can malpractice insurance to manage the audit risk and the potential legal liabilities. So the two components of the audit risk are the material misstatements and the detection risk, friends. Like, let me just tell you. So here we have the inherent risk and the control risk, right? So we have inherent risk and the control risk, and we do have the detection risk, right? So now inherent risk and the control risk are nothing but the material misstatements, whereas detection risk is the detection risk. So material misstatements were classified into two types, nothing but the inherent risk and the control risk. So let's understand a little more about them, right? And also why we need to do this audit risk, friends. What is the use of it? The actual purpose of the audit is to reduce the audit risk, and also to an appropriately lower level through the testing, and also through the adequate testing and with this sufficient evidence, because the creditors, the investors, and the other stakeholders, they completely rely on the financial statements, right? They cannot look at the each and every transaction that we have done, but they look at the final end, that the end financial statements, right? Now audit risk may carry legal liability for a CPA, or simply certified public accountancy firm, that is performing the audit work. So over the course of the audit, an auditor makes inquiries and also performs the test on the general ledger and also supporting documentation. So if any errors are caught during the testing, the auditor requests the management to propose for correcting the journal entries. So that data we are considering now. So yeah, finally we can say that the audit, after any corrections are posted, an auditor provides a written opinion as to whether the financial statements are free of material misstatement or not. So auditing firms carry malpractice insurance to manage the audit risk and also the potential legal liabilities. And if we talk about the types of audit risk, as we discussed, we have the material misstatement, nothing but the inherent risk and the control risk. So the material misstatement risk, so the common category of these two is the risk that the financial reports are materially incorrect before the audit is performed. Before the audit is performed, they are materially incorrect, friends, right? And also in this case, the word material, whenever I say the material, it refers to the amount. It can be the dollar amount, or it can be rupees amount, or any other currency that you take, right? And of course, the percentage of the amount is considered. It depends on the what kind of data we are taking. It can be the exact amount, or it can be the percentage of the amount. So let's say if an accounting company is having a balance of $1 million or 1 million rupees, I mean, whatever currency you consider, let's stick with dollars for now. So if this accounting company has an inventory balance of $1 million, so which is incorrect, if we take it as a $10 million or less than that, maybe some mistakenly written number of zeros are written mistakenly, right? Now, a stakeholder reading the financial statement may consider that as a misstatement. So the risk of material misstatement is even higher if there is a believed to be insufficient internal controls, right? And yeah, this can also be called as one of the fraud risk. Now, if we talk about the detection risk, so let's say here we have the detection risk. If we talk about the detection risk, it is the risk that the auditor's procedure do not detect a material misstatement. For example, an auditor needs to perform a physical count of the inventory and also compare the results to the accounting records. So this work is performed to prove the existence of the inventory, and if the auditor's test sample for the inventory count is insufficient, and it can also to extrapolate out the entire inventory. So the detection risk might get higher in this case. So this is about the detection risk, friends. So if you look into the inherent risk, let me just quickly, let's try to understand what is inherent risk, friends. So inherent risk is the risk which is caused usually by an error or an omission in the financial statements. So it's all about financial statements, right? So if there is an error or an omission of any character or any digit, any number in the financial statements, then we call it as an inherent risk. So there might be many influencing factors for it, right? It can be due to the failure of the internal control as well. So in a financial audit, inherent risk is most likely to occur when the transactions are complex or in a situation that require a high degree of judgment in regard to the financial estimates. So this type of risk represents a worst case scenario because as you all know, because of the all internal controls in place have been failed, right? And also, if you look deeper into the inherent risk, so inherent risk is one of the risks that auditors and also the analysts must look when they're reviewing the financial statements, along with the control risk and the detection risk, right? They have to look very carefully into it when conducting an audit or when they are trying to analyze the business. So the auditor or an analyst tries to gain an understanding of the nature of the business while examining the control risk and considered to be high. So an auditor can set the detection risk to an acceptably low level to keep the overall audit risk at a reasonable level. And to lower the detection risk, so it can be the inherent risk, control risk, or the detection risk. To control them, so we try to keep on reviewing the financial statements, right? It has to be acceptably as low as possible. So in this way, we can come up with the inherent risk, friends. For example, if you take for inherent risk, it is often present when a company releases the forward-looking financial statements, either to internal investors or to a public as a whole. And also, the forward-looking financials by nature rely on management's estimates, because they cannot access all the data and they cannot come up with the financial statements, right? So they try to consider the management's estimates itself. Yeah, and also they value the judgments of the management, and which actually pose an inherent risk. So this type of estimation should be disclosed to the financial statement users for clarity, right? So this is one of the inherent risk, friends. So I hope all of you understood, and let's try to look into control risk as well. So control risk is also one of the misstatement of the one of the type of the misstatement, the audit risk, right? So yeah, control risk, nothing but it gives us the probability that financial statements are materially misstated. So whenever we have the misstatements, we try to consider it as a control risk, and it can be due to failures in the control by a business. And when there are significant control failures, a business is more likely to experience undocumented asset losses. So which mean that its financial statements may reveal a profit when there is actually a loss. And also, the managers of a business are responsible for designing and implementing and also maintaining a system of controls that is very adequate for preventing the loss of the assets. And it is not easy to maintain a solid system, right? A solid system of controls, since the system must be periodically altered to fit ongoing changes in the business processes, and also as well as to deal with the entirely new business transactions. Also, sometimes the management may knowingly avoid the implementing the certain controls, so on the grounds that they are too expensive or expensive to maintain, or that they interfere with the smooth flow of the transactions, so which can straight away impact the customers. So the monitoring of a control is one of the key tasks for a company's internal audit department. Along with the inherent risk, it is very important to take care of the control risk as well. So when a control issues are found, they communicate these problems to management and the audit committee with the recommendations for the improvements to be made, so which can help to reduce the control risk, right? So I hope now you all got the basic understanding about what is inherent risk, what is control risk, and what is the detection risk. And all these three combined, we call it as a audit risk, friends. Now here in our example, we got various scores, like the about various types of risk we have taken, and finally we have formulated into audit risk. And at the end, this is my target column, friends, the risk column. So based on all these values, the aggregation of all these values, I'm defining whether it is considered as a risk or not a risk, right? By just keeping a simple threshold, I'm saying whether it is a risk or not a risk for the business or not. So let's go into the discussion, friends. Let's try to understand the coding part, how to implement the decision tree. So yeah, let me open the code. So again, today we are going to discuss in the Google Collaboratory. So I hope all of you got used to it. You do a simple Google search, you will be able to open a Google Collaboratory. Go to File and click on New Notebook, and you can start writing the code, friends. And of course, one of the interesting features of Google Colab is we have runtime, and you can quickly change the runtime type to a GPU. So you can actually run your program on the GPU, right? Instead of running on the CPU. So GPU is nothing but the accelerated computing, and within no time you'll get the results. Even you have a big data, like huge volumes of data, you can easily process it using a GPU. So that's the advantage of Google Colab, friends. And surprisingly, it is free. Of course, it also has various pro versions, but yeah, the free version works quite well. So if we let's get back into the code, friends. Like as we discussed, the business statement here is there are around total 777 firms, and we have collected the data from 46 different cities of a state, and yeah, these are basically listed by the auditors, and the targeted offices are listed from almost 14 different sectors. Like imagine there are like huge number of domains, friends, that are available. So one such domain is the accounting domain, of course. But yeah, different domains are there like healthcare, manufacturing, aviation, automotive sector, and life sciences sector, electrical, electronic, mechanical. So many sectors are there. Out of them, we have considered the 14 sectors data, and we have listed out. So this is the data that just now we saw. And then always the first step while writing the Python program is importing the libraries. So here I'm trying to import the pandas library and also the matplotlib and of course the sklearn. And in sklearn, I'm using the train test split, and then in sklearn pre-processing, we have the label encoder. So which helps us to convert our data into categorical data. And then I'm trying to read the data, friends. So in the next cell, so this is called as a cell. So in the next cell, I'm calling pandas. PD is nothing but pandas, right? So we have called import pandas as PD. So we just gave some alias name to it. So pd.read underscore CSV. So because my data audit data is a CSV extension dot CSV extension. So we have to call read underscore CSV. So that it can read the CSV files. And later on, I'm just trying to print the head, which prints the top 5 rows and info. So info will print the whether the column is a non-null column or what is the data type of each column. Everything will be given by data frame.info or df, or just simply the variable name.info. And then I'm trying to segregate my data into input and output, friends. So where X is indicating the input and Y is indicating the output. So except the risk column. So in this, except the risk column, remaining all columns are the inputs, whereas only the risk column is considered as output. So Y is output, X is input. So input is nothing but the independent data, independent columns, right? Independent variables. Whereas Y output is dependent variable. Output is dependent on input. Y is dependent on X. Risk is dependent on various types of risk. So this is how we have the data, friends. And then we are again trying to split the data. So let's say I'm trying to use a train test split to split my data. So sklearn dot model selection import train test split, and I'm trying to send my X and Y. And here I'm defining my test size as 0.25. So which means the test size is 25% and the train size is 75%. So totally it should be 100%, right? So no need to mention about the train size, automatically it is understood. Only if we mention the test size, that's more than enough. And of course we have a random state equals to 0, but anyway any number you can give. And next comes our data processing, friends. As part of data processing, we have the feature scaling, nothing but the normalization or standardization. So you might have come across these words like standardization and normalization. There is a slight difference, friends. Here we are trying to standardize our data. And of course, normalization as well we can do. Normalization is nothing but the normal distribution of the data or simply the Gaussian distribution of data. So usually the data that is available in the nature, like even though you consider the heights of people, ages of the people, and the length of leaves and the flowers, everything, whatever data that is naturally occurring, always it is under normal distribution. And whenever we have the data, the machine generated data, the data that is handled, that is generated by humans, might not be always in the normal distribution. So in that case, what we have to do is we have to normalize it, right? And or we can also standardize it. So what is the difference between normalization and standardization is both are same, friends, but the slight difference that we have is in normalization your mean and standard deviation can be anything, but whereas in standardization your mean should always be 0 and the standard deviation should always be equal to 1. And of course, mean equal to median equal to mode. So all the measures of central tendency are equal when we consider the normally distributed data and or standardized data. So for that, I'm using a simple standard scalar. So this standard scalar I'm defining SC equals to standard scalar and train data is equals to SC dot fit underscore transform. So inside that I'm passing the train data and then I'm calling the test data. So we have split it right in the previous cell using scalar model selection. So now I'm trying to apply the standardization for both train and also for test. Right, so we have seen till standardization, friends, and then we have the decision tree classifier. But before we further go here, let me quickly run the code and show you. So let me run one by one. Okay, so it's connecting, friends. It is initializing. The kernel is getting initialized. And also it is trying to mount the Google Drive. So you can click on the files and you can refresh and see if the Google Drive is mounted or not. So Google Drive is mounted and you can see all your shared drives as well as the My Drive, all the documents and all the folders you can see here. Yeah, so for now, let me close this and I have successfully able to run it. You can see the tick mark here. And let's try to print it, friends, print the data. So here I have df.head, but the print is missing. Let me quickly include print. So print statement. So whenever you have a doubt in Python, just try to give print. So it will tell you what data you're getting. So P is small, yes. And yeah, let me quickly run this. So you can see this is my data and these are the columns that we have. And finally, we got the info as well. So you can see everything is non-null. We don't have any missing values. So that's the reason I'm not doing any other pre-processing. But if you have the null values, you have to impute them. You have to follow the imputation techniques. So what are the various imputation techniques? Like we have mean imputation, median imputation, mode imputation, and many other techniques. You can get all these imputation techniques and many more other techniques from 360DigiTMG mind map, friends. So let me quickly open that and show you. So go to this URL 360digitmg.com/mindmap or do a simple Google search. You'll be able to find it. Then you have a simple search bar and you can select for the machine learning using Python and R. And you just need to select or double click on that. So you will be able to interact with this mind map. So you can see in machine learning, today we are going to learn, today we are learning the decision tree, which is nothing but the supervised technique. So if you double click on that, it will expand, friends, and you can see its various points, like it is a top-down recursive model. And also if we have continuous data, we need to discretize the data first. And rules are framed by splitting the variable based on the attributes. And splitting is done based on the variable. So with the high information gain. So we discussed it, right? Whichever has the highest information or where the gain value is so high, that is considered as the root node. And then we do have, based on the classification rules generated, the classes on the new data value is decided. right? So these are the some key points of decision tree. So these are the algorithms. But what about the data cleaning process? Just go back and try to select the data science. So let me, yeah, certificate program in data science. So try to click on that and you will be able to see the CRISP DM process. So yeah, CRISP MLQ process, my bad. So in that we have various stages that we discussed on the first day or second day of our session, day 2. So we have understanding the business problem, data understanding, and we do have data cleaning and data preparation. So try to double click on that, friends, and then you will be able to see various things like feature engineering, EDA, and data cleaning. So when we are talking about missing values and etc., it is all about data cleaning. So try to expand it. And when you expand it, you can see so many things like typecasting. So typecasting is converting from one data type to another data type, like converting from a string data type to integer data type. So this is one of the example for typecasting. And then we have duplicate. So most of the time in the transactional data, we do have duplicates. So how to handle them? And then we have outliers. So the two extreme values are the outliers. We need to treat the outliers, right? So by using various techniques like 3R technique, masking, winsorization, trimming, swamping. And of course, we do have here missing values. When we have missing values, we perform the imputation techniques. So what imputation techniques you can perform? Like let's say, so missing values at random, and these are the variants of missing values. Missingness not at a random, missingness completely at a random. And what techniques we can use to avoid them? We can use deletion methods like simple strategies where we have a case-wise deletion or list-wise deletion or complete case analysis, or simply we can go with pair-wise deletion or available case analysis. And then we have single imputation techniques. So these are the techniques that I stated just now. So mean imputation, median imputation, mode, and random imputation. Hot deck imputation as well, it is also available. Then we do have regression imputation, and of course KNN imputation. And we do have model based imputations like maximum likelihood EM algorithm, and of course the multiple imputation. So these are the various techniques, friends, that are available when you want to handle the missing values. But in our current data, we don't have any missing values. So we can just straight away go with the example. So of course, many other things are there. Yeah, here you can see the standardization or normalization. So it will make the data scale free and unitless. And we do have robust scaling. These are the conditions, like, I mean, these are the advantages of doing the normalization, right? And this is a method, the min-max scaling method, and this is used for normalization. And whereas for standardization, this is the formula, x minus mean by standard deviation, where we finally get the z-score. And of course, we do have the robust scaling, where we use the interquartile range, IQR, so which we can obtain from a box plot. So again, box plot is one of the graphical representation that we use to identify the outliers. And of course, we can get the interquartile ranges by using the box plot, friends, right? So these are few things that I want all of you to explore. Just try to go through this mind map, friends, and you'll gain an amazing knowledge which will help you further. So let's get back into our coding example where we are trying to run the code. So here we have the splitting of the data, so into train, test, split. So let me quickly run that. So after splitting, you can simply add anything. I mean, you can just print anything. Let's say I want to print the y train data. Let's say y underscore train. So try to give always the exact name, friends, and you can see the train data. Or let's say if you want to see only the first few values, you can give y train of head. Let me give this time print, or we can just directly give y underscore test dot head, or let me give print itself instead of head. So we can view the test data as well. So after that, we can transform our data by using standard scalar. So let me quickly run that. And then we can print and see, friends, how the data are looking. So let me write print x underscore train. Oh, I think I gave, okay, it is case sensitive. It is actually capital X. So I gave it a small. So let me quickly correct my mistake. Yeah, here we go. So we got the data. So previously it is the numbers, but here you can see we got the decimals. So after standardizing, this is how we got the data. So let me try to call the X test as well. So print of X underscore test. And let's try to run this. So you can see this is the data we have. And then here we have, friends, the decision tree classifier. And decision tree classifier is available in sklearn.tree. So we can actually look into its documentation to understand more about what is this decision tree classifier is all about. So let me open the documentation part. So you can see here sklearn.tree.decision tree classifier. This is the official documentation of a scikit-learn website, and you can just go to it, and you can open this and understand various parameters in it. So the first parameter we have is Gini, and we do have entropy, we do have log loss. So today we discussed about entropy, and there are also different kinds of criterion. So based on these criterion, we can classify our data, like Gini index as well as the log loss. So they also tell us about how much impurity we have in our data. And then we do have the splitter. So do you want to split the data as the best split or just a random split? So you can see the default values as well, friends. So when you did not mention anything, by default Gini criterion is considered, and even for the splitter, by default best is considered. And maximum depth, so how many branches you want, so this will tell us so what is the maximum depth of the tree. And then minimum samples, so the minimum number of samples required to split the internal node. So basically the minimum samples are 2 by default, it requires 2. And the minimum sample leaves, so the minimum number of samples required to be at the leaf node, so that also we can define. And then we do have like maximum features. So default none, we no need to mention anything. So the number of features to consider when looking for the best split. So it is also one of the key factor. And a few more things are there, like random state. So this controls the randomness of the estimator or simply the classifier, and the features are always randomly permitted at each split, even if the splitter is set to its best. And of course, we do have minimum impurity decrease and maximum leaf nodes, and so many options are available, friends. And we do have a simple example, but anyway, let's quickly move into our own example. So where we are trying to define. So of course, so many parameters are there, and only I'm interested in criterion as entropy, and remaining I want everything to be at a default values. So yeah, let's try to run our code. So once after we are calling the function, calling the decision tree classifier, then I'm trying to fit the data. So whenever I say dot fit, what I'm trying to do, I'm passing my data, I'm trying to build the model. So machine learning is all about predictive modeling. We try to build one model, give a new data, a test data or a new data, and finally get the result, finally get the predictions. So that's what we are trying to do, friends. So classifier dot fit, and then inside that I'm passing the train data as well as the input train data as well as the output train data, so that we are telling the decision tree that, hey decision tree, this is the input data and this is the output data. So once after we fit the model, so after running the classifier.fit, you can consider that your model is fit. And now you can predict the data, friends. So you can predict by passing the test data. So X test. Now it will return the predictions. So now we will be comparing the Y test with the Y predictions. Right? So for that, you can simply call a confusion matrix. So confusion matrix is a matrix that is used to estimate how many true positives are there, how many true negatives are there after getting the predictions. So now basically we try to compare the Y test and the Y prediction values by passing them into confusion matrix, and you can see we got 124, 0, 0, 70, which means our model is like almost 100% accurate, friends, like 124 true positives and 70 true negatives. So what is true positive here? So my actual value is positive, my actual value is positive, and my predicted value is also positive. So we say that as true positive. And then here we got 70 true negatives, which means my actual value is negative and my prediction value is also negative. So that is true negative. So when I say positive negative, don't misunderstand that your value, the numerical value that you got is negative. But here positive is nothing but 1, negative is nothing but 0 in our case. Because in my data, we have two categories, the positive category and negative category. Positive is nothing but 1 in our case and 0 is nothing but the negative in this current example. So I'm just trying to use the generalized terms, friends, so that you can understand and you can implement this particular technique not only for the audit data or not only for this audit risk data, but any other data you can use if you know the generalized terms. And then, yeah, this is how we can build a decision tree model and we can get the results, friends. Let me try to run the model, run the classifier. And yeah, we are successful. So then let's move on to the next step where I'm trying to plot my data. So for plotting, I'm calling one of the best known library in Python, matplotlib. So in the matplotlib, I'm calling a color map, a listed color map, where I'm trying to add my X train data as well as Y train data. So first I'm trying to map plot for the train data, and next I'll be mapping for the test data. So if both are same, it means my model is 100% accurate, right? So let's try to plot it, friends. So I'm giving a title for my model, for my plot, as a decision tree classification with the training set, and then I'm giving the X label as total and the Y label as risk, and finally I'm showing it, right? And here I have added a few arguments in order to give some certain shape to it, a rectangular shape and with a certain size. So let's try to scroll down and you can see. So we have green and white, green and red, my bad. So green we have all ones. So how many ones are there? You can see in the green. And how many reds are there? You can see in the, how many zeros are there? You can see in the red. So each dot indicates one observation, friends. Each dot indicates one observation. And then if we move further, so we have further the test data. So X test and the Y test. And my bad, it's not K9 classification, it is decision tree classification. So using decision tree classification, we were able to do for the test data. So X test as well as the Y test. So this is about the decision tree, friends. I hope all of you understood, right? And of course, it requires a Python programming expertise to learn more and to develop this kind of algorithm. So I strongly suggest all of you to learn Python. And in that case, you can simply go to our YouTube channel. So 360DigiTMG. So where we have like a bunch of videos. So on Python, we have created so many videos on Python. The live training sessions, like you can search for the name called Tame the Python. So this will help. This will help you to begin your Python journey from scratch. So it will really help you, friends. Please try to subscribe to our channel and also try to go through this videos playlist. So even though if you are learning for accounting and if you are interested in any other domain, so parallelly we have many other domain analytics going on, like healthcare, life sciences, marketing, and banking, customer, legal and law. So like almost 14 domain analytics are going on parallelly. So I request all of you to just go through them and try to watch them and understand the various use cases. And one more good news is like from July 11th, we are going to start a live Python programming session for free, and I request all of you to register for it and enroll for it and try to attend. So in a live session, you can attend the Python and learn the Python from scratch to advanced, right? From beginner level to advanced level, you can learn the Python, friends, right? So not only Python, and if you are someone who is looking actively to get a job in the data stream, like it can be data analyst, data engineer, or data science, or artificial intelligence. So we have like complete playlist for all courses, the latest, very latest courses we have, and you can quickly watch them. And of course, we do have various interview preparation sessions and resume building sessions. So I request all of you to subscribe to the YouTube channel and try to watch each and every video and gain immense of knowledge, friends. Yeah. So this is one thing I want to quote at the end. And of course, please try to follow our LinkedIn pages. So let me try to open the 360DigiTMG LinkedIn page, friends. So please try to send the connection request and please do follow the pages so that we are trying to post some of the interview questions, so which can help you to gain some knowledge and you can attend the interviews, which will help you a lot in the long run. So try to follow this page, friends, and yes, if you just look into the post, you can see various interview questions are posted every other day. So just a simple poll questions, and you can just try to answer them and gain immense knowledge. And of course, we do have various blogs in our website. So not only the mind map, we do have various blogs. We do have the digital book, and where you can simply just open the website, a simple Google browse, and you will be going to that. So you have blog, and you have various blog based on the data science, for domain analytics, for artificial intelligence. Just try to pick any blog and read it, and of course you can also contribute from your side into the into these blogs, friends. So try to use this opportunity. And yeah, we do have various other learning resources like interview questions, and you do have the digital book. We do have the mind map. So you can simply go and access the book. So you can access the digital book and actually understand each and every algorithm that we are discussing. And the entire examples, everything will be there in the book. So try to access and read it, which will help you a lot in future. So this is all from my side for today. And today we have discussed about the the decision tree, right? So today we discussed about the decision tree, friends, and we also looked into an example, the audit risk example, which is part of the accounting analytics. So thank you all. We'll try to meet again tomorrow to understand one more interesting use case in accounting analytics. Yeah. Thank you all. Have a great day.